Today's lesson is from section 2.5, and it'll be the first part of transformations of functions. So here, we're just going to go through all the different transformations you can have for your functions, and there are 5 different types. So let's run through them real quick. So vertical shifts are when, if you have a function of f of x, and you add c or you subtract c. So adding c of value of c means that you're moving your graph up that many units, and if you're subtracting c, then that means you're moving your function down that many units. Okay, so here I have a quick example. So the function of f of x is equal to x squared. I already have that graphed. So for x squared plus 3, that means that I'm moving my graph up 3 units. So every value after I plug it in, so let's say you're plugging in 1 squared is 1, that's where they get this first part from. Okay, but then I add 3, so that moves it up 1, 2, 3. So now my point is all the way up here. Okay, and then that's the same for all my points. Okay, so then my graph moves up. Okay, same thing if I'm subtracting, I move it down 2, it looks like in this function, so everything would move down 2. So then I get a function that looks like that. Okay, so that's adding and subtracting outside the function. Inside the function, if I subtract, that shifts my graph to the right that many units. If I add inside, that shifts my graph to the left that many units. Now the reason why it's kind of the opposite of the one above is because of what that parentheses does, or what you're doing to your function. It kind of messes it up, because if you think about solving a function, and let's say you have x plus 2 equals 0, okay? Now right now it's a plus, but if I was to solve for my function, I would subtract, making it the opposite. So I get x equals -2. So in a sense, the function is always trying to find that middle, okay? So to get it to be back to where it's like, which is 0, so getting it back to 0, it always have to plug in the opposite value in for x to make that happen. So that's why it's always moving it in the opposite direction. So here I have x cubed graphed. Now I went for my graph by 2's, so it's easier to put in this picture. Okay. But here, if I have x cubed graph, then if I do x minus 2, that means I'm moving it to the right 2 values. So each value will move to the right 2. Okay, so here, this top one will not be 2, 8 anymore, it will be 4, 8. And you could even plug that value in and see what happens. So if you plugged in 4 into this function, 4 minus 2 gets you 2, 2 cubed is 8 now. So if you plugged in plugged in 2 now, 2 minus 2 would be 0, 0 cubed is 0. Okay, so it actually shifts all your stuff over like it's supposed to. So we get a function that looks like this. Okay, and then for the other one, we're adding 1, so it's moving it to the left. So everything moves to the left one. Okay, so you get a picture that looks like that in purple. Okay, let's move on. So reflecting is the next one. So if you're multiplying your function by a negative value on the outside, that reflects your graph over the x-axis. If you are multiplying by negative on the inside of your function, then that reflects the graph over the y-axis. Okay, so examples of inside the function and outside the function is usually like inside parentheses or some qualifier, or it's attached to something like that. So like here for radical, I have square root of x already graphed, but if you can see that we have negative x on the inside and we have negative x on the outside. Okay, so that radical being like where the negative is located changes which way we're flipping our function. Okay, so for f of x of negative square root of x, then that means that anytime I plug in a value, so let's say 0, square root of 0 is 0, 0 times negative 1 is 0. So we stay right there. Okay, but then if I plugged in 1, 1, square root of 1 is 1, 1 times negative 1 makes it negative 1. Okay, so then you get a flip. And then here, if I plugged in, it's like 4, and I just picked perfect squares, so they're easier to graph. But if I plugged in 4, square root of 4 is 2, 2 times negative 1 is negative 2. So then we get that flip over the x-axis like we talked about. Okay, now if it's on the inside, then if I'm plugging in my 0, 0 times negative 1 is 0, square root of 0 is 0. Okay? Now here, think about what we would have to do to make this other one. So like, if I'm plugging in 1, negative 1's not going to be an okay number, right? It's an imaginary number underneath the radical. Square root of negative 1 is not possible. Neither is square root of negative 4. So we have to plug in something else to make it work for us. So let's say we use the opposite of the opposite, right? So if I plugged in, instead of 1, you plugged in negative 1. Okay? So the negative 1 negates the negative that's already in there. So negative negative 1 is 1. So the square root of 1 is 1. Okay, so we're getting values that we're supposed to be getting. And we're not getting imaginary numbers which are not possible to graph on a regular coordinate plane. So if I plugged in, let's say, negative 4, then I would get negative negative 4, which is positive 4. Square root of 4 is 2, right? Okay, so then I get the other value that I was supposed to get. But look what happened. We reflected over the y-axis like I stated up above. Okay, so we're getting kind of a picture that we're supposed to get, but it looks a little different because we flipped over this line, and for the other one we flipped over that line. Okay, so make sure you take those things into account, especially with the radicals. You don't want imaginaries, so that's why we have to go with the other ones, or the negatives of those numbers. Okay, now here we're going to be talking about stretching and shrinking, vertically and horizontally. So if we vertically stretch and shrink, that means that we're multiplying our function by a scalar number on the outside of the function, or to the entire function. So if this value of c, let's call it, is greater than 1, then that means it's stretched vertically by a factor of c. Okay? That means it's pulling it like towards infinity and kind of stretching it that way. Okay? If it's in between 0 and 1, then that means it's shrinking, so it's pushing it closer to the x-axis instead of pulling it away from the x-axis. Okay? So here I have the absolute value of x, and I already have that graphed. So if I multiply that by 2, then every value of this x value is stretched by a factor of 2. So 0 is still 0, but 1 becomes 2, and negative 1 or positive 1 on the other side becomes 2 as well, and then we get 4. So we're stretching it up. So notice how it becomes closer and closer to that f of x line. Okay. If we do a half, then it shrinks it so it's pushing it down towards my x-axis. So instead of 1 for a y value, I get half. And then for instead of 2, I get 1. Okay, so we get pictures like that. So horizontally stretching and shrinking is just doing the same multiplying, but inside the function. So if c is greater than 1 and it shrinks it horizontally by a factor of 1 over c, so it's like half, okay, or some other number depending on what c is. If you are in between 0 and 1, then that means that it's stretching it horizontally by a factor of 1 over c. So if I have x squared here, and I put a 2 out there, or put a 2 inside the function instead of outside the function, then that actually becomes 4x squared. Okay, so then now, all these values that I had 1, so now instead of that, it's going to be 1/4, or like 4. So 0 is still going to be 0, but then you get 4, and then 4 will be 16, so you're all the way up here. Let's say this is 16 up there, okay? Same thing there, and same thing there. So we get pictures that are, oop, that one's a little off, there you go. Much better. Okay, now that's kind of like stretching it vertically is the same thing as shrinking it horizontally. So what they're trying to say is you are shrinking it like pushing it together. If you were thinking of a accordion, when you push all the things together, you're shrinking it, and then you're not pulling it out. So stretching would be pulling the accordion out away from you. Okay, so if I do 1/2 x all squared, then I get 1/4 x squared. Okay, so then now all my values become the other way, which is kind of like shrinking vertically, but you're also pulling those values out away from the f of x line. So those are kind of like the same thing in essence. So the opposites for like your vertical. So vertically stretching is the same thing as horizontally stretching. And then vertically shrinking is the same thing as horizontally shrinking. Or sorry, vertically stretching is the same thing as horizontally shrinking, and vertically shrinking is the same thing as horizontally stretching. Okay? So they're kind of like the opposites. So here, let's graph some. Now we don't need to have our XY tables to do this. We can start with the parent function. In this case, it would be x squared. And we've already graphed that several times in this video. Okay? So now, if I start with x squared, then let's say we do the next thing. So you work from the inside out. So the next thing is that you have a value of -3 inside. Okay? So that means we're moving our function to the right 3 units. So every value, we move 3 to the right. Okay? And then we want to multiply. So then we're going to vertically stretch our function. So every y value becomes times 2. So 1 will be 2, and then 4 will be 8. Okay? And then from there, we want to add 2. So we're going to move everything up 2. I'm sorry to draw over the directions, but that's no big deal. Okay? So we went from green to blue to orange to red for our final graph. Now you don't have to draw out all the pictures. How about I show you in this next one how you can just do the dots and then you can make the line for the final one. Okay? So here if I have a graph for this function of negative square root of 2x plus 5, okay? The parent function is square root of x. So if you remember what we graphed for square root of x, with those points, you can draw the line for that if you want. But here, let's just draw the dots for the rest as we're moving, okay? So for negative square root of 2x plus 5, the next thing would be closest to the x is that 2. So since it's on the inside and it's a value that's greater than 1, then we are shrinking it horizontally, okay? So everything gets shrunk horizontally by 1/2. If you think about what it would be if it was just 2x, so think about your 0, it's just 0 still. But then 2 is going to be 1 times 2, so that makes it 2. So square root of 2, now this is going to be a weird number because it's going to be because we're underneath a radical. So square root of 2 is going to be 1.4, right? So we get a little stretch or shrink that way. And then same thing for 4. 4 times 2 is 8. So the square root of 8 is 2.8. So go from 2, goes up a little bit. Okay? So we get that picture. Okay? And you can make the line, but then we're going to add a 5 to that. So since we're on the inside of our function, okay, that means we're moving to the left 5. Okay, so 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Okay, so we get those points. And then for our final one, let's go with purple. And we get our negative square root of 2x plus 5. Okay, so negative square root of 2x plus 5. Remember, a negative on the outside of the radical flips it over the x-axis. So all these values go on the opposite side. And then that would be my final picture. Okay? Alright, have fun.